Hey guys, this is my very first video that I'm making. Just preparing for if I do have the baby early. I went ahead and started with chapter 3. So you may be watching this or you may not be, maybe getting this live in person. But I wanted to go ahead and prepare for anything. So let's go ahead and get started with 3.1. You'll notice that this chapter is kind of a mini chapter. If I go back to the table of contents, you'll see there's only 3 sections. So there'll be 3.1, and this is advanced linear solving. And then 3.2 is systems with 3 variables. Section 3.3 is calculator skills and just learning how to use the Inspire. So I kind of call this like the hodgepodge chapter, things you need to know that didn't really have a place to go. They're like the outcasts, and so I put them together into one little mini unit. You won't be tested over it. It'll be a double quiz, and that'll be the last grade for the quarter. With this section, typically students struggle a little bit, so I'm going to try and help you as much as I can, give you as many hints and tricks as I can, but definitely reach out to other teachers if I'm not there and try to get help, seek out other students, and just try to practice this as much as you can. Whether that means you need to print out another blank piece of this homework page and do it over and over, that's what I would suggest doing, because practice makes perfect with these kinds of problems. So just a few little notes. The first thing is, if you're solving an equation for x, that means what the entire goal of this is that you want to isolate the x. So you want to get x by itself. And that's a lot easier said than done, right? Sometimes a rule of thumb for me I like to think about is doing PEMDAS backwards. If you say PEMDAS backwards, it's SAD-MEP. Whoops, misspelled that. SAD-MEP. So what that means is, if I'm trying to solve for x and trying to get x by itself, I'm going to add and subtract the numbers first. Then I'm going to multiply, divide the numbers second. And then I will do the exponents and the parentheses last. And that will isolate x. So kind of put that practice into play with number 1. So I'm going to highlight my x's, and this is one that's pretty simple. You've probably seen something like this in Algebra 1. But I want to get all of my x's on one side, and I want to get all of my numbers on the other side. And that's the primary goal for any equation. So I could do 2 steps in one. I could subtract 7x. And then I could subtract 12 on the left side. So when I do that, 10 minus 7 is 3x. If I subtract 12 from the negative 3, I have negative 15. So notice how I've added and subtracted first. Second step now in SAD-MEP would be to multiply, divide. So if I'm trying to get the x by itself, I'm going to divide both sides by 3. X equals negative 5. All right, number 2, there's a couple things you could do here. What you'll see with these problems is there's really no right or wrong way. There's several ways you're going to approach each problem. So you can do it the way that I do it. If you did it a different way and end up with the same answer, that's probably completely okay. I want you to try this problem, though, and just see kind of where you end up. And then we'll go back through it and talk about what I did. So typically with this kind of problem, I do see parentheses. Like I've said, sometimes you can do those last and it would work out. In this case, I want to get rid of the parentheses because I see 2 of them. Don't really like them there. And the only way I can get rid of the parentheses is by distributing the number that is in front of the parenthesis. And so I circled the -3 and I circled this minus sign because this is like saying -1. If I distribute this, I have 10 minus 6x plus 12 equals 5x. If I'm distributing or if I'm multiplying by this -1 out in front, I now have minus 3x and I now have minus 7. So what that negative out in front has done is it's flipped the sign for the 3x and for the 7. Then I can combine like terms on each side. And then solve for x. So go ahead and do that. So you end up getting 29/8. That's okay that it's a weird fraction. You're going to get weird fractions. Don't think you did it wrong because it doesn't come out to be a nice clean number. In Algebra 2, it's okay to get ugly fractions. Doesn't mean you did anything wrong. Okay, number 3. Now we're going to start talking about, or we'll see 2 examples where we now have fractions in them. And anytime you have a fraction in any equation, I personally don't really like fractions. Do you guys like fractions? No. So I want to get rid of the fraction. And you get rid of a fraction by multiplying by the least common denominator. So I can get rid of, I'm going to circle all of my denominators. 5, 3. I've got 2 of them. Can you tell me what the least common denominator is for that? 15. So 5 and 3, least common denominator is 15. And whatever I do to the left side, so if I multiply everything by 15, if I'm going to multiply by the least common denominator, I'm going to have to do it across the whole thing, up to every single term, which means there's 4 terms. Then what happens is I can either, so I'm going to show you the long way, but I think you're going to prefer the short way better. So if I'm multiplying this first term by 15, I've got 15 times 3x over 5. And I didn't multiply it out, but you could have to get 45. But I'm just going to leave it the way that it is, unsimplified. 15 over 5, that reduces to be what? 3. 3 times 3x, that gives me 9x. Now I wrote all of that out, and that's the long way, is writing it all out and then crossing out. But with these fractions, you know that they're going to simplify because we did in fact multiply by the least common denominator. If I know that they're going to simplify, I'm just going to go ahead and do it up here. 15 over 5 is 3. 3 times 3x gives me 9x. So try it with the second term. 15 over 3 reduces to 5. 5 times 2x gives me 10x. On the right-hand side, I'm literally just multiplying these by 15. There's no denominator, so there's nothing to cross out. So I have 15x plus 30. Now this makes this problem a whole lot easier than what the long way of getting rid of the fractions would be, finding a least common denominator, combining these two, then cross multiplying. It's kind of a nightmare. This way is, in my opinion, much easier. So then I'm going to go ahead and finish this problem out. 19x equals 15x plus 30. Subtract the 15x. So x equals 15 over 2, which I got by 30 divided by 4, and I went ahead and simplified. Number 4, okay, I've got 3 fractions here. I'm going to circle my denominators. 1, 2, 3. 3 denominators. And all three of these denominators, if I want to find the least common denominator, it's what they all have in common. So what could I multiply to get rid of all of these fractions? Well, 5 and the 3, we've already decided is 15. So I know 15 is going to be in the common denominator. But I also have an x here, and if I multiply this first fraction by 15, that's only going to cross out the 15, but it's not going to cross out the x. So I need to add an x to my least common denominator. So I'm going to write 15x over all three of my fractions. Then I'm going to look at 15x and 5x. If I were to reduce, or if I were to cancel these, 15x over 5x would reduce to be 3 on top. 3 times 3 is 9. Second fraction, the 15 and the 3, reduce to be 5. Nothing cancels with the x, so I have a 5, an x, and a 2. So that all combines to be 10x. And then go ahead and try the last fraction. You end up getting 3x because you're left with a 3, an x, and a 1. Now I just solve. So 9 equals negative 7x. X is equal to negative 9 over 7. You notice 3 out of the 4 were funky fractions, and it's okay. We're getting rid of the fear that everything has to be nice and neat. You can have a messy fraction, and that's okay. Okay, number 5, just kind of looking at it, as x plus 10 is in a square root, and I want to isolate the x. So this whole thing is square rooted. If I want to get rid of this square root, what's the opposite of square rooting something? Squaring. But whatever I do to the left side, I have to do to the right side. So when I square this square root, literally all that happens is they cancel out. And so I'm just left with x plus 10. That makes life really easy. They just cancel each other out. On the right, if I've squared 4, 4 squared is 16. So x equals 6. Those are nice and easy. Number 6, we've got another fraction. I'm going to circle the denominator since there's only one. The least common denominator is 2. So I'm going to multiply everything by 2. Now, you look at this and you're like, why did you only write 1, 2 on the right side? Well, that's because this 1/2 is out front in front of the parentheses. So if, I'm going to show you this because some people are going to be able to look at it and understand it and say, okay, this 1/2 is out in front, so that means it's been pulled out or taken out from the x and the negative 3. It's like what they both had in common. So I only have to apply that to the 1/2. However, if you did this the long way, so if I distributed this 1/2, I'd have 1/2 x minus 3 over 2. And so then if I multiply that by, I multiply everything by 2 here, and then obviously the 5 by 2. Should have probably written this in a different color. So I'm multiplying the 5 by 2, the 1/2 x by 2, and the 3 by 2 because I want to get rid of this fraction. And I get 10 equals, the 2 and the 1/2 cancel, so I have just an x. The 2 and the 2 cancel, and I just have x minus 3. Now, I'm going to show you, if I would have just, if I didn't distribute it up here, and I would have just multiplied the 2 to the 1/2 and the 2 to the 5. I would also end up with 10 equals 2 and the 2 cancel, 1 parenthesis x minus 3, which that 1 out in front doesn't do anything, so I can just drop the parentheses. If you feel more comfortable distributing first and then multiplying everything by the least common denominator, that's perfectly fine. I'm not going to judge you for it, but I am just showing you a shortcut. So either way works. Just choose whichever you prefer. So then to solve for x now, super easy. Add the 3. X equals 13. Now number 7, I've got this 2/3 out in front. You can choose the short way or the long way. I'm going to show you the short way, and I'm going to show you the long way. I'm going to show you both. Short way. Least common denominator is, don't look at anything in the parentheses right now. Least common denominator is 3. So multiply by 3, multiply by 3. I've got 15 equals, 3's cancel, 2, parenthesis, 5x minus 6 fifths. Distribute that 2, 15 equals 10x minus 12 over 5. Okay, here's where I've got another fraction I need to get rid of. So you might have to actually do this process twice. So if 5 is my least common denominator, I'm going to multiply everything by 5. 15 times 5 is 75. 10 times 5 is 50x. 5's cancel, minus 12. So 50x equals 87. X equals 87 over 50. If we did the long way, so if I went ahead and distributed, use a different color, I'm going to come over here and do it. I would have 10x over 3 minus 12 over 15. And then I still have this 5 over here. So, you know, when you're multiplying fractions, you just multiply the tops and then the denominators. Just multiply across. Now I have 2 fractions I want to get rid of. The least common denominator between those is 15. So I multiply, I'm going to use a different color. 15, 15, 15. This way might have actually been shorter. And 15 times 5 we already said was 75. 15 and the 3 reduced to be 5. 5 times 10x, 50x. 15's cancel, minus 12. Then you get right to back to where you started. 87 over 50. Okay, I want you to try number 8. I'm going to go ahead and circle these 3 fractions. Try solving for x with these. Well, the least common denominator between all of these would be 12. I'm going to multiply everything by 12. 12 over 3 reduces to 4. So I've got a 4, 2, and an x, so 8x. Reduces to 3. 3 times 7 is 21. 3 times 12 is 36x. And 6 minus 6. Then I solve for x, so I get all of my x's on one side, all of my numbers on the other side. So you end up with 28x equals 27. X equals 27 over 28. probably got that answer and you were like, that is weird fraction, but that's okay. Okay, the second half, so I call this part B. The front was part A, it's just solving for x. The second page is part B, solving for the indicated variable. I cannot tell you how often this type of problem shows up on the SAT, ACT. All the time. And it's really a higher order thinking problem because you're so used to solving for x, like you're trained to just solve for x. And the reason why this problem is very different is because, one, it's going to have multiple variables. And what I mean by variables is it could be A, B, C, like look at number 9. It's got a P, an L, and a W. So it's got 3 variables going on. Your answer will not just be a number. So answer will not be a number. It will have variables in it. So you're not going to get 5 for your answer. Your answer is going to be, L equals W plus P over 2 or something. I don't know. So the whole goal of this is to isolate that variable, whatever you're solving for. So here, number 9, we're solving for W. So we want to isolate the W, get it by itself. And the PEMDAS backwards still applies. So if we look at number 9, if I want to get W by itself, my suggestion is always to circle or highlight the variable that you're trying to get by itself, because your answer is not going to be correct until you have something that is W equals blah, 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 blah. Okay? That should be your final answer. And then so our goal is to get to that. So first up, I could subtract 2L from each side. And I've got P minus 2L equals 2W. I'm going to highlight this W again. So to get the W by itself, what would I need to do? Divide by 2. So my final answer would be P minus 2L over 2. And I am very, very happy if you leave it like this. In fact, sometimes I prefer it. I will say, though, that on the SAT or ACT, that the answer choices may not have this as an answer choice. It may go ahead and break it up into 2 fractions. So if I were to break it up into 2 fractions, it would look like P over 2 minus, okay, if I had 2L over 2, the 2's would then cancel and I would just have L. So I would accept either answer. Sometimes, like on my test in particular, I would probably just stick with this because I'm going to accept it that way. Sometimes we will lose points by trying to simplify and doing it incorrectly. So why not just stop whenever you're ahead, not try to mess anything up. But if you're doing an SAT problem set or something, you might see an answer like this. So I'm going to show you both. All right, try number 10, solving for R. So I'm going to highlight R. I want you to try it. So first step, if it's attached to pi, I'm going to divide both sides by pi. And I have A over pi equals R squared. And I want my final answer to be an R equals, right? So, an R squared equals is not fully finished. If something is squared, what's the opposite of squaring something? Square rooting it, right? And then those just go away. So then if I've now have R equals the square root of A over pi. And just leave it like that. I know your answer doesn't look very clean and neat, but just leave it. Square root the whole thing. Don't just square root the top. A over pi is square rooted. Okay, number 11, this is something we're more familiar with, solving for y. It's like getting it in the mx plus b form. So try solving for that. So you've got negative 5y equals 8 minus 3x. Or you could say negative 3x plus 8, either way. Divided by negative 5. You could leave it like this. 8 minus 3x over negative 5. You could also break it up. So you've got negative 8 over 5 plus 3 over 5x. Or it could be flip-flopped, 3 over 5x minus 8 over 5. Either way, but you could certainly just leave it like this. Or these could be switched. There's several variations of this one that you could do. Okay, number 12. This one is one that I think that you will be able to do. It has fractions in it, just like the first page, part A of this lesson. But we're solving for y still. We're solving for x now. So my answer is going to have a y in it. But I want you to try this one. Okay, so first thing I'm going to do is multiply everything by 5. So this gets multiplied by 5, this gets multiplied by 5, this gets multiplied by 5. If you wanted, you could have distributed the 4/5 first or not. That's okay too. But I'm doing the shorter way. So you have 5y minus 15 equals 4 parentheses x minus 2. Go ahead and distribute the 4. Oops, why did I put an 8 there? 4x minus 8. And then if I want to solve for y, oh no, I'm solving for x. I don't know why I keep doing that. If I'm solving for x, I'm going to go ahead and circle my x. And I want to isolate that. So I'll add 8 onto the other side. Then I'll divide by 4 on both sides. So x equals 5y minus 7 over 4. Or you could have broken that down to be 5y over 4 minus 7 over 4. But either way, good with me. I would prefer to just kind of stick with the original and not split it up, but either one works. Okay, these last 4, or I guess 3 out of the 4, what if my variable that I'm solving for shows up more than once? So what if multiple b's, or b's, or on number 16 ends, I've got multiple of them. So basically, like, what if there's more than one? There's a few steps that I'm going to take you through that work every single time. If you use this 3-step formula, 3-step process, I promise you, you will never, ever, ever get these wrong. But these are the most missed problems in all of Algebra 2. That's pretty daring to say that, but I'm very confident these are the most missed questions in Algebra 2. And this year, we are not going to miss these. We are not going to miss them, okay? I'm determined. So follow these steps. Go home, write them down, tattoo them on your arm, do something. But we are not going to miss these, okay? So let's look at number 13. This will be our kind of our skeleton, our example problem. So I have, if I'm solving for b's, I'm going to circle both of them. I've got 2 of them. And what I want to do, first of all, I want to get all b's on one side. So step number 1, get the b's on one side. And then everything else that doesn't contain a b goes to the other side. Everything else on other side. So this problem, we started out kind of easy because it's already done that for us. I've got my b's on the right side, and then this b doesn't have a b in it, so it's on the left side. Step 2 is I'm going to factor out the indicated variable. So I'm going to factor out b. So what that means, if I'm factoring something out, it's like they both have that variable in common. So you can look me straight in the face and you can tell me this term has a b and this term has a b. They both have a b. So what it means to factor that out is I'm going to put a b out in front, parenthesis. If I've pulled the b out, if I've factored it out, that means that there's no longer b there. So what's left over? 1/2 h plus r. Now, if you are like really self-conscious and worried that you did it wrong, imagine if I foiled this back out. If I went ahead and redistributed the b, I would be right back to where I started. I would be right back to where I started, right? So that's just a good way to check and make sure you did it right. Last step, final step. I told you this is a 3-step process. Divide by stuff in parentheses. Super philosophical here. Divide by the stuff in parentheses and leave it be. Okay? If I divide by the stuff in parentheses, 1/2 h plus r, 1/2 h plus r, this cancels, and my final answer is b equals v over 1/2 h plus r. And leave it as is. I'm done. I am done. Now, if that fraction on the bottom really bothers you, then you can flip it and put the 2 on top, and it would be 2v over h plus r. But I'm not going to make you get into that technicality because I just want you to follow this 3-step process. So I would certainly just take something like this. All right, number 14, same thing, okay? Gonna circle all of my b's, 1, 2, 3. Step number 1, get the big B all on one side, everything else on the other side. So that means AB plus BC minus 3B all need to be on one side, and the 10 gets the boot to the other side, negative 10. Now, if you wanted to bring these over that way, that's also okay. It would just mean all the signs are flipped. And if you're checking the answer key, it's just a good rule of thumb. If you're checking the answer key and you got the same answer as me, but all of your signs are flipped, you still got the right answer. Just all the signs are flipped. That's okay. They're the same thing. So now, did step number 1. Step number 2 is factor out the B. So parenthesis. If I take these away, I'm left with A plus C minus 3 equals negative 10. Step number 3, divide by the stuff in parentheses. Negative 10 over A plus C minus 3. And I am done. Don't touch it. Don't touch it. Don't touch it. Okay. Number 15, solve for x. This one doesn't actually have multiple x's, so we're not going to use these 3-step process. but it does have multiple fractions. So brainstorm how you would get rid of these. Well, I'm going to have to multiply by the least common denominator twice. So I'm going to multiply this whole thing by 2. And, I don't know why I did that. Parentheses. 2, 2. 2's cancel. I've got 2 over 3x plus 7 over 4 equals 6y minus 2. And then I do the process again. Let's go ahead and finish this problem out. I'm going to have to multiply everything by 12. So I have 8x plus 21 equals 72y minus 24. And I'm solving for x, so I'm going to circle it or highlight it. I want to isolate the x. So subtract 21. And then divide by 8. So 9y minus 45 over 8. Don't think that reduces. Okay, last one. This is a multiple n scenario. Got one here. Got one here. This is the most missed problem in the whole world. In the whole world of Algebra 2. Most missed. Hands down. So we're going to go through it very slowly. The reason why this 16 looks different than 13 and 14 is because why? Well, it's got variables on the bottom. And it looks a little scary. But what do we know about when we have fractions? What have we learned this section? When we have fractions, we multiply by the least common denominator. Well, I've only got one denominator. It's this. So my least common denominator is what? Rn plus a. So when I multiply it on the right side, okay, well, it just goes away. And I'm left with Pn on the right side. On the left side, if I multiply I times Rn plus a, it's like it gets distributed to both. So I have IRn plus IA. Because it's like two different terms. Now it looks like number 13 or 14, and I can follow the three-step process, or better yet, you can follow the three-step process. So go ahead and finish out this problem, and if you do, then you have solved the most missed problem in all of Algebra 2. So I want to get all of my n's on one side. IRn minus Pn equals negative IA. Or you could have just moved the IRn to the other side. Either way, does not matter. Factor out the n. Left with IR minus P. Negative IA. Divide by stuff in parentheses. So my final answer is negative IA, IR minus P. If you did it the other way, then you would get positive IA over P minus IR. Either way. Okay, so homework is 3.1. Please talk to other teachers if you have questions. Mr. Weiss is there. Miss Napier is there. I hope that you guys are doing well. I miss you guys a lot, and thank you for sticking with this and working hard. I miss you guys. So I'll talk to you soon.